Okay, so the next thing we want to talk about are the half angle formulas. And they are similar in a way to our double angle formulas, only in this case we have some strange looking things going on, which I'll have to explain later. But for right now, here are the formulas. We have the formulas. Oops, let me get my pen from drawing all over the place where it doesn't need to be. We have the formulas here that tell us if we have the sine of half an angle, sine of alpha over 2, it will be the same as the positive or negative value of the square root of 1 minus cosine of alpha over 2. And similarly, if we're interested in the half angle for cosine, we're going to take the positive or negative square root of 1 plus cosine of the angle, the full angle, over 2. Tangent of alpha over 2 has three different formulas right here. I won't read them off, but we'll go through and we'll employ them as we go, and I'll come back later and verify these things. So what does this mean? What is really going on? Well, again, let's try and illustrate. We're told in this example that the sine of the angle theta is negative 3/5, where the angle theta is between 3 pi over 2 and 2 pi. So we have this angle. There's this angle in the plane. And in this angle, theta is given to be an angle somewhere here in the fourth quadrant. So somewhere in the fourth quadrant, we have this angle theta. In standard position, that's where theta is. And so for this particular angle theta, we know that if we were to draw our right reference triangle, we would have a triangle where the opposite side would be negative 3, the hypotenuse would be 5, and so the adjacent side would be 4 by our Pythagorean identity. What are we really looking for? Well, when we say the sine of theta over 2, it means that whatever the size of this angle actually is, doesn't matter. Take an angle that is half of that size and place it somewhere over here. So somewhere maybe in the first quadrant or the second quadrant is half of the original angle. That is theta over 2. When we say half an angle, we mean we're interested in the sine, cosine, tangent of this right triangle where we're taking half of the angle that we were given. So we're asked, well, what would be the sine of that triangle? If this were 330 degrees, this would be the angle 115 degrees, and so on. So what would we do? Well, sine of theta is equal to negative 3/5, so let's use the formula for the sine of theta over 2. We're told that the sine of theta over 2 is equal to plus or minus the square root of 1 minus the cosine of the angle theta divided by 2. So here's a question. Where does this plus or minus come from? And I'll point out that the plus or minus is based on the location of the angle alpha over 2, or theta over 2. So we look for the quadrant in which theta over 2 terminates in, and we'll note that if theta is between 3 pi over 2 and 2 pi, we can actually figure that out relatively easily. And the way we're going to do it is this. Since theta is between 2 pi and 3 pi over 2, then what would theta over 2 be between? Well, take all of these numbers and divide them by 2. That is, multiply by 1/2. So 1/2 times 3 pi over 2 gives me 3 pi over 4, and 1/2 times 2 pi gives me 1 pi. So in other words, theta over 2 is an angle between 3 pi over 4 and pi. So what does that mean? Well, because the angle theta over 2 terminates in the second quadrant, then we're taking the positive number of whatever we get from our root. So sine of theta over 2 will equal the positive value of whatever we get under our root. So now we're going to substitute in what would we get under our root. Well, under our root, we have 1 minus the cosine of theta. So that's 1 minus the fraction 4/5 all divided by 2. So we're going to have to simplify this down. This is the square root of 5/5 minus 4/5 divided by 2 over 1 if we want to put it in the most complicated way possible. So what we're really dealing with is under this square root, 1/5 times the reciprocal of 2 over 1, that's 1/2. And if we reduce that, we have 1 over the square root of 10, a positive number this time. So sine of theta over 2 in this particular example is going to be equal to the positive square root of 10 divided by 10. Well, that's actually not so bad once you know how to find whether that plus or minus is positive or negative right here. So we want to check the quadrant. Now cosine of theta over 2 we should recognize is an angle that is going to be in the second quadrant, making this a negative for the value of cosine. So if we substitute into our formula right here, we're going to have 1 plus 4/5, which is the cosine of theta, all divided by 2. So carrying out our particular calculation right here, we're going to have 5/5 plus 4/5 all over 2 over 1. 4/5 all over 2 over 1 right here. So this is going to become the negative of the square root of 9/5 times 1/2, and for some of the same reasons that we talked about over here. And so we're going to get negative square root of 9/10. If we reduce that, we would see, well, that's the same thing as the negative 3 over the square root of 10, or rationalizing our denominator, we should say negative 3 square root of 10 over 10. All right, so what about this thing? Well, we can take it to be tangent of alpha over 2 is the square roots. Just divide these two things and take a big square root. But we don't have to use a square root formula every time. We can use one of these bottom two. That's the nice thing. So what should we substitute in? Let's try with this second one. And the reason why I say that is that I know that sine of theta is going to be a single fraction. And if I have a fraction within a fraction, all I want is just a single fraction of the denominator. So all I have to do is invert and multiply by whatever I get into the numerator. All right, so tangent of theta over 2, what will we get? I'm going to use that second form right there, so that's going to be equal to 1 minus cosine of theta. So 1 minus the cosine of theta, which was given as 4/5, would be divided by the sine of theta. The sine of theta is negative 3/5 here. All right, so working out our numbers, we've got 5/5 minus 4/5 in the numerator. And we're dividing that by negative 3/5. So working this through, we're saying we have positive 1/5 divided by negative 3/5. Interestingly, when we invert and multiply, we're taking 1/5 times negative 5/3. And so our tangent turns out to be negative 1/3. So that's what we're looking for right here, and you can see how the formula, the half angle formula, is affected. Be very careful of this particular item right here, and that is where we're getting the value for our sine in front of the sine or cosine half angle formula, and it's based on the quadrant that the half angle terminates in. All right, more to come.